Okay, so I turn on my recording. So let me share my computer screen. Again, as I say all the time, if something goes wrong, please wait for some time, right? I'll try to reconnect and things. It happens in technology, so we try to be more prepared for those type of things, right? Okay, so first thing first, right? Okay, so this is my unit. I'm continually improving this, right? I'm trying to include things, so you need to keep on checking on that, right? Let's go about difficult part now, yeah? The assignment. Can I go here now? Yeah. So this is the first assignment. We need to start now because it's a week 3. So we gotta do something about it. Can I open this first? Yeah, before opening the first assignment, can I open this team project task, right? Yeah. What I am planning, you see, this is the group I have allocated for you guys. Okay, so it's a random allocation. There is no any biasness, nothing. Okay, I just use the system to randomly allocate you guys, right? Okay, so if you find something conflicting things here, you can see the numbers here. Yeah, so the group members, so you can, like, I divided into 3 groups. There are 12 students enrolled, but I think some of them are inactive, so that means they may pull out from the unit. Okay, or they may not continue. In that case, of course, we will have some, so we will continue with that, right? This is I just use the random allocations of the team, right? Yeah, so you can see where you are, right? Yeah, in this group, and then let's try to communicate each other, right? Communicate each other, and then start doing the project. What it is about? What it is about? Can I go back now? Yeah, it is all about your knowledge, because you see, in master's degree, right, in master's course, we usually are interested only for the, like, research type things in our learning, right? What we have done, I have done here is, can you go inside the team research project? Okay, so there are 3 files I have uploaded for you. Okay, so these are the one to guide you. So there are 11, sometimes 11, sometimes 12. This system is just fluctuating. But anyway, look at here. So there is a presentation template. What you do, can I open up this slide one? Oh, it doesn't open. So I'll open from my assignment folder. All right, okay. In this case, that's not the one. I want the other one. So 2022. And then that's the assessment item, the first assessment item, right? Can I do? Okay. Okay. So this is your first assignment item, all right? So I have just given you that it's a week 6. You need to submit on Monday. So we have around 3 weeks time, right? Okay. So just right now, around 3 weeks time. So but we need to start this, right? What we need to do, let's see, yeah. So this is it is 30% marks, right? So you write a report, right? What you need to do is, this is a team project. So look at my writing. Usually team of 4 students, right? But again, depending upon the enrollment, it may be like 3, it may be 5. Okay, I'll think a little bit flexible on that, right? So you need to prepare a report. The objective is, look at this. These assessment items develop student ability to conduct a research project. Later on in your degree, you will be starting a project. You will be doing like a 2 credit unit of planning and another 2 implementation. So you need to do project. This is little bit of practice. If you want to do project on soil mechanics, okay, or foundation, or related with soil, geotechnical engineering. So what I want you to is start developing that skill now. It will be easier. Otherwise, that's very tough to do over there. So in this case, you do the topics. Look at here. I have given you the topics. These are a little bit advanced topics. Of course, we don't cover in our unit. All right. It is a little bit above what we cover, right? So what I want you to is, if you have one particular topics, advanced topics in geotech, you do the investigation. You do the investigation means you go to the literature and then you summarize what they say about that topic, and then you get some data from the literature, you analyze data, and you make a little bit of very good knowledge of that particular topic. It's a free topic, right? You can choose any topics if you want other things, but let me know first, right? For example, look at the advanced ground modification techniques, right? Look at here, first thing. Okay, you went to work as a geotechnical engineer, and you encounter one very bad ground. Okay, it's very unsuitable, expensive clays, so many things. What you would do? I didn't teach you in my geotech engineering that type of things, right? Because I just covered the common fundamental things only, right? So what you do is, okay, how can I learn about this? How to improve this ground? Yeah, and then what you do is you start investigating that. That's what exactly I want in this assessment item. It can be soil reinforcement, right? You see, to improve the soil, we put geotextiles, geogrids, metal stripes inside to make this more stronger. Okay, of course, I cannot cover that a lot in my unit, right? What I do is you investigate. Okay, so you can choose any one of those topics for your team. Just discuss within team what is good. Yeah, any topics, but even anybody wants to ask question? Is okay? Okay. So any topics you want to choose, right? But also not this whole topic. You can choose one particular specific topic within that. It's free for you. You choose one of the topics, plus please, one team choose one, right? Don't two teams don't choose the same topics. Okay, that's the main thing. All right. Any, for example, look at this critical state soil mechanics. This is a different concept. Unsaturated soil mechanics, that's a different concept. You see, soil dynamics, you see, you won't work, right? There is a machine. We need to design the foundation for a machine, right? Vibration, it gives to the soil. How we design that? How we analyze the soil dynamics thing? So you can take any of those topics. Within that also, it is okay. Just the one within that particular topics or any other topics that interest you. How you start? Okay, let's say I wanted to do soil dynamics, right? I copy this, I type this. I go to the Google. Okay, look at here, starting. Okay, I'm not telling you, you only go to the Google, right? Yeah. So what I'm telling you is you go to the Explorer and then go to the, can I show you now, Google Scholar. Not just Google, but Google Scholar. Yeah, you went to the Google Scholar site now, right? Okay, let's say I'm interested to investigate about soil dynamics. And I go to the Google Scholar and I press here, right? And I put that soil dynamics. Okay, look at there. There are many books, as well as there are many journal articles. You see, published articles. You can find that. This academic one is not just the Google search engine. I'm using the Scholar part, right? So I know there are some papers. And that some of the papers, for example, microsite variation, soil dynamics within newly tree fall pits and the molds. You see, this is the particular topics now, right? Which one I'm interested in? Maybe I go, let's say one of the very good, I will choose the recent one, let's say since 2019 version only. Okay, I don't go too old literature, right? It's better to be in the new type of literature. And I open up, look at this. What's that? Soil dynamics, garden soil, exploring the role of, yeah, there are very, look at this, right? For example, soil liquefaction in seasonally frozen ground during 2016 earthquake. You see, when there was an earthquake, oh, I want to know how it is. Can I go inside? You click on this. Many of the papers you cannot access from here. You see, this is the good paper, maybe for your research, but you cannot access from here, right? You need to pay or something, get access. So what you need to do, you copy the title if you want to get access, and then go to the CQ library, okay? Look at here. And then in library, you log in. Okay, so there is a library the option. Oh, that's okay. So and then you paste this title in the search engine. You wanted to get that paper out of it, right? You go to the search, and it should ask for my. So look at this. This is the paper, right? That paper is available here. If I click there, then it may ask me to log in or full text available. You see? And I get login, right? Yeah. If I go in, so I need to put my username and a password, right? Yeah, from there, because my computer is already logged in, so it automatically allows me to go inside, all right? So now I can get this full paper, you see? So download this article, you see? And I downloaded this article, look at here. Come on, taking some time, but it is downloading, so let's see. Come on, look at my internet or something. Okay, look at this paper. So now I first learned the abstract, what is all about, how they do it. There is an introduction, literature review, background, everything is there, right? Yeah. So, and at the end, oh, I want to know more about particular thing now, right? So there are list of references at the end of paper. You see, now look at the references here. That many references. So now you can access to any of those papers through CQ library, right? So you built on your skill, built on your skill, built on your skill, and then go inside, what we call it is to dig deeper about the subject matter. And at the end, you summarize results. I want like this. Okay, this is one of the journal articles. Of course, it depends on different topics, right? It's different for everyone. So I want exactly like this type of journal preparation from you. Okay, so I have provided the reporting template, and at the end, right, in I think week 7 or 8, you guys in a team, you will be presenting for all of the classes. Okay, so what you found about that particular topics. Can you start, guys, now? You can choose any topics within your group, right? That's fine. I don't mind, but it should be a little bit more advanced level. It's not just the basic, for example, okay, sieve analysis cannot be topics. That's too simple for you, all right? You cannot do like an effective stress principle because that's the fundamental in soil mechanics. You can't say like a Mohr circle. That is too fundamental. So you need to choose a little bit advanced level topics and you investigate about that topics. Any questions regarding this? It's okay, right? That's how we do the research investigation. Could you please discuss each other and start doing, preparing this? It's not like there is no one right or wrong answer. This is preparing you how you investigate about a topic that is new to you. You don't know how you investigate and do research. Is okay? Can you do that, please? Start that right now, all right? If you don't have any questions, so I will now move on to my lecture. Okay, that's how I show you how we start investigating about topics. So you see report template is also there, how you write report, right? And then there is a presentation template also given. So you need to present at the end. So overall, you will get around 30% marks from this research paper. Okay, you can build on, for example, we learn a little bit new methods in what we call it bearing capacity. Okay, so there are a few new things we learned already, shallow foundations, bearing capacity. Okay, so now, why, if you want really, okay, so based on the literature, which method is the best out of those methods? I think that was the question asked by Kasun, right? Which method I use? Yeah, so can you investigate based on those literatures, like new scientific literature, right? They reported some values of bearing capacity from the pile, the loading test, plate loading test. So which method gives the accurate result? You can investigate that too. You see, you can further extend what we learned until now. So you need to choose the topics, please, free, and you do the research investigation. All right. Is it clear? Did I make clear about this? Okay. Now let's move on. Move on to my, what is my teaching things? There should be somewhere. Yeah. So go back. So this is the resources. We are week 3. Week 3 means we are starting pile foundation today. All right. Please, guys, do ask questions if you want, whatever, whether it is clear or not, but I'll start now. Okay. So let me connect my writing pad first. So that I can indicate what I'm talking, so it will be easier. Of course, I have prepared this lecture slide in detail. I'm not going to do all of these line by line. I'm not going to read those, right? That's up to you to read. Read that. Come on. Okay. I'm not going to read those things in detail, right? What I will be doing is I'll be summarizing few important formula, important steps, important approach, and then we will be doing the numerical solution. That's how we learn things, right? How we practice here, so that you know how these formula are applied in real situation or the numerical situations, right? That's, we start deep foundations. I'll take 2 weeks for this because it's a big thing. At the end of next week, I'll try to introduce Australian standard, right? Because you see, there is a standard, because this is, okay, about the, what they call is footing and the foundations, right? Yeah, footings and a pad, residential slabs, and so on. So I'll introduce at the end of next week. But let's learn the first engineering principle first, right? Once we know the engineering principle, and then that standard I will be later on, not only for pile, I'll also look at the pad also, like a shallow foundation also, right? Australian standard for both of them. I'll start. Why I wrote piles here? Of course, deep foundation is pile, isn't it? But our focus in pile, right? Not many other different types of pile foundation. If you want to do research in other type of pile, the deep foundations, that's up to you. Okay, you can choose those topics. That's for sure. Let's start now. In terms of our unit learning outcome, we are still in the piles, right? Not only piles, we'll be learning about group piles also, right? Because we already, shallow foundations, we already cover, right? Yeah. So we are still in the unit learning outcomes 1, because 1 is all about the content knowledge. So that's what we are doing. So for today, I'm not talking about whole unit learning outcome. What I'm talking about is in deep foundations, what are the learning outcomes? First, we will learn about types of deep foundations. Okay, one of them is piles, right? Others are casings and those type of drill shafts, so on. But we will learn about types of foundation first, and then how we classify piles. Now we will focus on the piles only. Okay, we'll not go to the other type of foundations. Classify the piles, and then how they transfer load, how the piles they transfer load, and then how we estimate the bearing capacity, or what we call, I wouldn't call bearing capacity, just we call the capacity of piles, right? That's okay. And then settlement, how they settle, single as well as group, we will do that. But look at this, once you know these fundamentals, you can design pile foundation, you can design drilled shaft foundations, you can design all our casings foundations, right? So foundation design really is not a big thing. It is just application of the bearing capacity knowledge. So you can change the size of pile and spacing so that you can design any of the foundations. So I'll focus only the first 4 this week and next week. Is it clear what we are learning today? We are learning these things. We are focusing on piles, right? We'll be focusing on how to calculate load carrying capacity of piles. Okay, let's move on. Look at the piles topics. I have summarized all the topics in pile foundation or deep foundation, to be fair. But we will be looking at only the pile as well as types, length of piles, how they transfer load, how the bearing capacity of single pile as well as groups. Where is the group? Yeah, pile groups and the settlement. So these are the main topics I'll be covering. The other, how we drive piles. I'll show you some diagram, okay, with some videos, right? And then how other type of foundations are designed. So I'll not go to that one. If you want to choose one of the topics, for example, how you see well foundation, how we design caisson foundations for your research, that's good. Okay, this is the extra thing to learn from outside of your unit. So that's how we will be doing this week and next week. I'm not going to. Do you know why we need to use deep foundation?
Soil.
Because soil near the surface is not good enough to carry the load, yeah? So we need to put the load transfer deep into the, deep into the ground. That's it. There can be many situations, right? For example, you can read that, okay? Sorry, I'm not going to read those, okay? So that's up to you. There is a high water table. You see, water table is high. That means what? Bearing capacity is low. If there is a water, bearing capacity of the foundation is low, so it's better to transfer into the hard stratum below. Sometimes when we excavate, right, when we excavate, it is too expensive to remove the soil and put the foundation at the bottom, right? So you can put the pile in. So there are many cases you can read that, right? Pile does a lot of things. So deep foundations, again, deep footings, or it can be piles, piers, or caissons or wells. Okay, so we will be focusing mostly on piles. Deep footings, that is not that good. It's too expensive to excavate the soil and put the footing in the deep and then so on. So don't try to waste money and resources. Yeah, so just use the piles. That would be easier. Okay, so what they do, I'm not reading that again. So this is, look at, this is pile. One thing it does is usually transfer the load in the hard strata below, straight, because this layer is not that strong enough to carry the load, right? Another thing is, even if at the bottom, right, for example, sometimes it doesn't reach the block, like a hard rock or bearing stratum, still it carries the load through friction on the side of the pile, yeah? And it can be a little bit sometimes when we load lateral loading, lateral loading also, because piles are long and then they are confined with the earth, so they can carry the lateral load also, horizontal loads, right? And also there are maybe sometimes swelling of soil at the top, but there is a stable soil underneath. It's better we go inside the deep soil layer and then put the piles tip over there so that it can carry better loads. Or it can be like, for example, in this case, right? In this case, sometimes there is an uplift pressure, right? Sometimes it goes up. I think I'll talk about negative skin friction later on, right? So if then because of the friction, the piles, the soil holds the pile in its place, right? Or it can be sometimes at the top is erosion, so that even though it is eroded, what happens? Because of the deep foundation, the pile at the top, still the structure is safe, or structure is stable. So that's how we use the pile foundations in the bit, but you see in different situations. Usually pile foundations are used if the bearing capacity at the surface of the soil or close to the surface of the soil is not, surface of the ground is not strong enough to carry the load. Okay, so that's the reason. So you can read those all. So types of piles now. I have classified the piles into different types based on what type of material we use. We can use steel, we can use concrete, you can use timber, or sometimes it can be composite. So steel and concrete are the most common one. Okay, these two. Concrete can be either this cast in situ, where we cast over there, or it can be precast and we push into the ground. Okay, so based on the method of installation, how we install them, construction, it can be displacement pipe driven. We hammer it and put inside. Good, yeah. It can be what? Just the drilled and then cast in. We can put the concrete in and it hardens later on and it becomes a pile. And it can be combination of both. Some part we do cast in situ, and then some part we do the what, the driving, the piling. All right, so that can be combination. How they transfer load, based on how they transfer load is we can in bearing piles, right? That means they transfer load at the tip of the pile. You see the pile? When the load is transferred from here, then we call it end, or sometimes some textbook write point, right? Point bearing piles. Okay, that's the same thing. Over here, we call it point to the bottom, right? Let's say this is a ground. So if the load is transferred entirely, or most of the load is transferred from the end of the pile, then we call it in bearing pile. If the load is transferred mostly through the friction, side friction, you see this surface, then we call it skin or friction piles. Some, of course, in many cases it will be both, right? The load is transferred from the tip as well as load is transferred from the skin, the shaft of the pile. So it can be both, many cases. So look at this type, based on material, based on how we install them, and based on how they transfer load. Good? It's clear, right? What we are. So let's go through. I'm not reading this all, right? So for steel piles, okay, there are some advantages, there are some disadvantages. You can have a read. And so sometimes this is what we call it H piles, H-shape piles. These is steel piles anyway, right? So H-shape piles. So what happens is when we drive this type of piles, there is a, I think I have later on the, you see, swell goes inside that. You see, swell plug forms inside here. You see, so that means it becomes like a one big one. So there are different sizes of the HP. Okay, so some people they write D1, D2. What is D2? D1, D2. This is the two sides, right? But some people they call it, this is BF and that's D. Okay, just the representation. What it matters is just that we need to calculate area to calculate the load carrying capacity, right? So how we calculate area is that's how it matters. Is it clear? So the steel piles, we can use the pipe type steel piles, or it can be the H type. All right. Move. Oh, that's there. Oh, this is the, yeah, how the swell plug forms in the steel in between this. This is the swell there, right? Okay. Thanks. So concrete piles, it can be either the precast we drive in, or it can be cast in situ. Over there we construct it, right? So there are some advantages, there are disadvantages. You can have a look, and the different sizes also explained in this diagram, right? But again, different size depends on the country you work, because they have the standard sizes of these type of things, right? Yeah. So you need to check the local code where we are working in order to find the different sizes and shapes of the piles, concrete piles. So now sometimes we do the timber piles, we use the timber with connection and so on. There, of course, timber piles are a little bit more what, susceptible to moisture, yeah, on the ground. So it's not that recommended if water table is very high to use. But of course, we do use timber piles also. Sometimes mix of all materials, we use the composite piles. Okay, so based on the materials, it can be steel, it can be concrete, it can be timber, or it can be combination of all. Okay. Okay, types of pile based on second method is based on installation, how we install. Sometimes we call it driven piles, which is the displacement piles. Sometimes we just cast in situ over there. Can I show you some video how it is done? All right, discard that, and then if you click here, I think it plays, but it's better if I play from my downloaded file, so it will be easier for you to see. Okay, take a break a little bit, and then now we will be looking at how they are done. Where is the pile tube? First, I want to go to the steel tube, how they drive. This is the pipe, steel pipe, right? Okay, just can you see? Can you hear the? Yeah, it's okay. Good. Yeah. Steel pipe. Okay, steel pipe pile. If you see something is pushing from the top, it's a driving in, right? The steel. Oh, it looks very easy, yeah. Yeah, how they caught it now, yeah? They mark it and then they just cut using the, if it is too long, okay. How can I start this? Come on. Yeah. So that's the one, right? So that's how they drive. Like this is one of the case, right? We call it like a pipe, steel pipe with the palm. So we are pushing in. So sometimes we can do just a quick one. It doesn't take a long time. So how we do cast in situ, the second type one, and I show you just it's about 3 minutes.
Continuous flight auger piling is a fast and economical piling method, ideally suited to wet or granular ground conditions, which otherwise would require the use of temporary casings to support the ground. Pile depths of up to 32 meters depth can be achieved using powerful crawler-mounted drill rigs. A CFA pile is constructed by rotating a full-length auger into the ground to the required depth. Auger diameters from 450 millimeters to 1200 millimeters are common. The auger has a hollow stem, which is connected by a flexible hose to a concrete pump. The hose and stem are charged with concrete before drilling commences. Once the auger reaches the required depth, concrete pressure dislodges a temporary cap at the base of the hollow stem, and concrete is pumped under pressure into the ground while the auger is withdrawn, carrying the excavated soil upwards. Different designs of auger cleaner require the auger to either be stationary during extraction or to be slowly rotated in the same direction as used when drilling. Soil is floated up the auger and is removed by an auger cleaner just above the ground surface. Once the tip of the auger returns to ground level, concrete pumping ceases. The accumulated soil is then cleared away from the pile head. Then a prefabricated reinforcement cage is plunged into the pile while the concrete remains fluid. Special attention to the concrete mix design is required to maintain its workability and to ensure that the reinforcement cage can be inserted to the required depth. The piled concrete is allowed to set before nearby piles are constructed. Piling contractors. Think safe, work safe, home safe.
Okay, so that easy. How easily they do this type of things, right? Now is most of things are automatic, right? It can be driven automatically with the help of computer assisted program. You can cast in situ also, concrete powering inside, automatic. Many things are nowadays. You don't need to worry about that much how it works. Is it okay now? Based on the method of installation, there are two types, right? Either it's a driven or it's a cast in place, right? Where they cast over there. It's good? All right, okay, move on. So that's the two videos there. I have provided the link if you wanna have a look, right? But those files also I have uploaded in my lecture notes, so it should be fine to have a look. Come on. Okay, move on. As we see that, right? When this pipe, that was what I was discussing before. Can I just enlarge it? So that you see, that's the swell plug forms in the center. You see pipe, that was what we saw in the video. Okay, so this plug is also forms part of the pile now, right? Because it's full inside, the soil is inside. So this is also work as a pile. But sometimes we need to use both plug and then pile weight to calculate some bearing capacity or capacity of the piles. Of course, HP piles, of course, has piles. Some people they call has piles, sometimes people they HP piles. Again, that's the same thing. So also forms the plug, right? In between, this is the swell plug, and then this is the steel part in the flames and the whip or whatever we call it that one. Okay, so this is how when we drive the piles in. So these are the two types of swell plug will form. Okay, third is based on the what we call is load transfer. Load is transferred from only the tip, load is transferred only through the shaft, or load is transformed through both shaft and the tip. Okay, that we classify end bearing, which is sometimes they call it point bearing, friction piles, sometimes we call it skin friction piles, and sometimes both of them. You see how the load is transferred to the ground, either through the shaft or at the tip point. So there, that's how we classify. Which is the most common one, do you think? Which method, which of the type is most common one? This one, right? Most of the piles, they carry the load from the tip as well as through the skin. But there is a little bit more research about something now. So I'm going to explain that next. Okay, that's what it is written. Usually what we do, if the load carrying by the tip of the pile is more than 80% of the total ultimate load, we call it end bearing piles. Same thing, if from the skin or the shaft, okay, if 80% or more load is carried by the shaft, then we call it skin friction or floating piles. But most of the general case, this is the general condition, it carries the load by point as well as shaft. Some people they write QES, QF, don't confuse with this, right? One is from the skin, this part of the pile, another load is carrying from the tip of the pile. So ultimate load is the sum of both, but there is a little bit of adjustment because of the weight of the pile and the swell replaced, if we are replacing the swell, isn't it? Yeah. Otherwise, mostly the ultimate load QU equal what? Load carrying by the tip, we call it point, plus load carrying by the shaft. So this is the case. But one research have found now, little bit surprising result. Both of them, they don't reach the ultimate at the same time. when this is reaches the ultimate, the other part is some part, some, not all of it is utilized. If this reaches the optimal, depending on the swell type, right? If the shaft load carrying capacity reaches the ultimate, what they call ultimate capacity, in that case, this may be not the fully. So it's like what we call, I think you read this, I'll just highlight this one first. Okay, there are a lot of research, so you can read that. Ultimate in-bearing capacity and ultimate friction capacity, right? These two things, they don't occur at the same time. Okay, so look at this. This is a pile, right? At the tip, as well as in the shaft, right? Both, they don't occur exactly same time. They are a little bit offset. So one is optimum, other is not optimum. That's what is the observation made. But this is so hard to find out what is what. So usually what we do is look at here. Q ultimate equal Q point plus Q shaft. But what we do is usually Q allowable, we use some big factor of safety so that what? That particular disturbance is minimized. Do you understand what I mean? So both ultimate point, they don't reach the same point, but again, that is so hard to find out those. So what we do is we try to calculate ultimate of both and use factor of safety to be safe side. Okay, so that's what we will be doing in this unit. So there are some investigation I have listed here, right? How they transfer the load, how the swell plugs form. This is from this textbook, right? Yeah, and then how the load transfer is done with the depth of the pile for different type of swell, right? It's a cohesive swell, and how it is dynamic, time dependent, after a few hours, how it changes. Okay, you see, there are a lot of research going on. So again, this is just the information for you. This is not what we can do now, right? This is the research investigation type things. Just letting you know that point bearing capacity and the shaft bearing capacity don't reach at the same time. So there will be the disturbances, right? Okay. So there are many factors that affect the, when pile is driven into the swell, response will depend on the many factors. Number one, how much volume of swell is replaced by the pile because of the swell plug things. Some are like what they call closed in piles. Another is it depends on the amount and type of material, overburden material. Piles penetrating in soft clay layer in the stiff clay, because you see if it is top soft and the bottom layer is stiff, when you drive the piles, what happens is it carries this thin layer of soft clay with it into the next level down. Same thing, there is a large volume piles, right? When it is going in the clay, what happens is, look at this. When this is a very stiff clay, right? This is a pile, but what happens is when you drive, the crack develops in the top. You see, those type of things because of the driving force, right? So what they suggest is sometimes if you are penetrating the piles in the very stiff layer, clay layer, so first top part of 1.2 to 1.8 meter length of the pile can be neglected, because you see swell is already cracking, also swell is already failing. So there are many other considerations required. How much you need to know, that's up to you, right? So what I'm giving you some idea about things from the book. So let's do the basic thing now. So pile capacity. How we find those pile capacity? You already know, right? Q ultimate is what? Q of point plus Q of what? Shaft, right? How we find? But before that, I need to know the pile capacity. Pile capacity depends on structural capacity. This pile material itself, how much it can hold, whether it cracks pile itself. Another is geotechnical capacity. Which capacity we are interested in our unit? Of course, this is structural engineer guys. They will calculate, okay, how strong the pile is, right? Concrete or steel, those type of things are structural engineer, they do that. How many of you are enrolled in the structural program in our degree? Oh, yeah, then, oh, both of you, right? Okay, two of you are in municipal program, isn't it, right? those guys who are enrolled in structural program, I think you will do few more structural unit and then learn about how the structural capacity type of any member, structural member, right? But for us, we are interested in geotechnical capacity. Okay, geotechnical capacity also have the two, you see, pile capacity, structural geotech. This is failure in soil is geotech, failure in pile is structural. Okay, so in this case, right, failure from the bearing capacity, we need to do that, or failure from the settlement. Again, you remember my limit state design method. One is settlement, another is stress, right? Bearing capacity and a settlement, we need to check both of them. So we'll be looking at only the geotechnical capacity. I'm not looking at the structural capacity of pile. Good. Okay, how we find the geotechnical capacity now? Yeah, we are looking at that. Geotechnical capacity of the piles. Geotechnical engineers have developed methods how to calculate geotechnical capacity of the pile. Look at that now. There are 3 methods available. First is you need to do the pile test, full scale pile test. You make a pile and you drive into the ground, and then you will test how much load it can carry before failure. It is expensive, right? Okay. You make a pile and then you test on the ground in the real fully scale load. That is hard. Second method is sometimes we analyze the soil because we know the soil material properties, and then we do the static methods of calculating those. Static methods also, you see, it depends on the soil parameters only. So other are in the test method. So there are different methods, right? In situ test or soil parameter in the lab, as well as we can have, you see, there are pile driving formula to calculate. Look at this, 3 major ways to calculate, calculate the ultimate bearing capacity of the pile or axial load carrying capacity of the pile. But for us, we will just focus on mostly these methods. Okay, these are the static methods. So we will use some of the equations to calculate those, right? In our unit, of course, this is too expensive, and this is different way of getting the ultimate capacity, but we will be looking at only the soil properties. Based on the soil properties, we'll be looking at for the cohesionless soil, or we can look at the cohesive soil. Sometimes we also look at the rock. Cohesive soil, there are several methods. And the cohesionless soil, cohesive soil, there are, we call it 3 methods, alpha methods, beta methods, gamma methods. It's very interesting, okay? So we will be looking at this part. So in our unit, from now on, I will be looking at only those methods, how to calculate ultimate load carrying capacity of the piles. I'm sure you have done some of these methods in your undergraduate, but hopefully I'll extend your little bit knowledge to go a little bit more detail about these methods, okay? Any questions up to now? No, right? Okay, here you go. So I have provided the description about full scale test, static method, dynamic method. So, but we will be, in our unit, we will be looking at the static analysis only, not the dynamic as well as pile load test. So there are static pile capacity depends on 2 things, right? First, again, pile capacity, let's say PU equal what we call it, P point capacity, PU plus PSU or whatever they write. Okay, they write different things. Again, ultimate capacity is point capacity plus shaft capacity. Okay, so that's the main thing. These are the methods used. Look at this summary of the all methods, how you calculate what is QP at the tip and what is QS along the shaft. You see, this is the along the shaft. So we try to get QU equal QP plus QS. Again, we learn one very good thing, right? They don't reach ultimate at the same time. Okay, so we try to make sure even pile load test shows that they don't reach ultimate at the same time. But again, we don't know exactly how it works inside. So what we do is we calculate ultimate of both, and then we try to use factor of safety in order to compensate those differences so that we are safe in design, right? So There is a general bearing capacity equation. Then we can use the Hansen method. We can use the Terzaghi method. We can use the Visick method. We can use the Jambu method. Meroff. This is very important. Okay, this is most commonly used method in PAL, but again, others also we use. And there are based on SPT values, CPT values, Cole and the Castello method. Look at the methods. What we are looking at is only, I'm looking at in these methods, we are looking at only the point capacity now. These methods are used for only the point capacity. For the shaft capacity, we call alpha method, beta method, and a lambda method. I'll talk next for this, maybe in the next session, all right? For now, let's look at how we calculate at the point, at the tip of the pile, at the end of the pile, how we calculate. These are the methods we use. Can I summarize them? It is a little bit confusing. This is the general capacity equation. Ultimate pile capacity point, right? I'm talking about here, the capacity only over there at the tip of the pile. Okay, this is the area of the tip, area of the point. What is the area at the end? That's the area, right? And then what is the, what we call it, there is a calculation, bearing capacity calculations, right? Pressure. So if pressure, if we multiply these two, so you get bearing capacity. Let's call this bearing capacity, and this is the area. You get the total load carrying capacity of the pile over there, right? This is the equation we use. This is the same. Look at this. This is the first term of the bearing capacity equation, isn't it? C term. Can I write our bearing capacity, what we learned before? What we use, Q ultimate, right? Yeah, Q ultimate equal, what was the formula? CNC plus what? Q, this is the average overburden pressure effect, QN, Q plus what? What was that? Half B N gamma, right? So that was the, oh, there is a gamma also. Gamma also. So this was the equation we use. That's the same equations is here. There are few variations here. That's what I want to talk. So this first term is same except the correction factors, right? Yeah, it's the same equation, bearing capacity equation. But they have included like this value. You see this, I don't know how you pronounce this. This is one of the factor. This factor is 1 except for Visick method. Okay, everything is 1, but Visick method, it proposes this. Okay, Visick method is proposed is using the N value this. So we can include N. All others are same, right? So there is no difference. Another thing, interesting thing is this third term in the equation we can neglect. We can just ignore this third term. Can you guess why? Why the third term of the PAL foundation does not give that much of bearing capacity? We can neglect the third term very easily. The reason is how? Look at this. What is this? This is the width of the foundation, right? How much width you have in the PAL at the bottom? Let's say diameter or width. Very small, right? Of course, it will not be more than a meter or so. So that means these all values becomes very small compared with other values. Okay, so that, can I show you now? You see, you can easily neglect this, the last one, because pile diameter is small compared with the what? The length of the pile, isn't it? So that means this term doesn't affect. We'll do tutorial today, okay? So you will see how much is the effect of the third term. So only the first two terms are important. You understand now? Of course, depth factors, DC, right? They are important. Why? Because it is going in the deeper depth. But the SC factors, this is the shape factor. How much the shape changes in the tip of the pile? You see, maybe circular, maybe close to square, or maybe H pile. Oh, not this way. Come on, this way, right? So the shape, there is not much the shape difference, you see, in the end of the pile. So what that means is shape factor also doesn't affect that much. Only the factor that affects is what? First two terms of the bearing capacity equation and depth factor. So depth factor is given here, you see, DC and a DQ. In the table, or there are equations also to calculate those things. So what we learned until now is depth factor matters, only the first two terms in the bearing capacity equation matters for the pile, most of the piles. Good. So that's why when you, sorry, when you combine them and ignore the last term, you can write this. Why these guys write in this way? Look at this. This is area. This is the first term. You see, they already ignore SC term, right? There is no SC, no shape factor there most of the time. And then they use negative -1 because just to remove this when there is no, this is only the, what they call cohesion only in the swirl term because NQ value. But again, guys, this NC, NQ value, these bearing capacity value are not exactly same as shallow foundations. They are different because they are in a very great depth, right? Overburden pressure effect will be quite different than the shallow foundation because you see piles, we are talking about the tip. So this is a very long pile. That means we need to use the different bearing capacity factors. Okay, but look at this. There are discussion here. We can use the Hansen method, Terzaghi method as we have in the shallow foundation. But you see, I have written some comments here. Shape factor is usually 1, but some of the times we can also use those proposed by those authors. But then very negligible effect anyway. That will not be big effect. So this is the same as the bearing capacity in the shallow foundation table. Hansen method, Terzaghi method, same equations and the same table we learned last week, last 2 weeks. But Bisick method, this is the third method we are learning. This NQ value is given by this formula. Look at this, how good they are. How big is this formula is, right? Bisick method. So it depends on many things, including this, we call it IRR. This is, we call it rigidity index, reduced rigidity index. It's given by this formula, okay? And then again, IR is calculated by another formula. Okay, keep doing, look at this, guys, okay, that one. And at the end, they get in what? NQ dash, bearing capacity factor for the second term. And then they use NC value, this formula, to calculate what? NC dash. Why we don't have N gamma dash? Again, third term in the bearing capacity equation is not that interesting for piles. It contributes very small bit of it. Okay? Do you need to know these all equations? Yes, you need to, but just to use in the problem. It's not to remember all those steps, right? Also, Jambu method gave straight value, like a NQ value, how it calculates, and we can use the same value as Hansen method to calculate the NC factors, right? First term bearing capacity factors. So this is the table given. So I would suggest you use table for Bisick and the Jambu method because calculating using this equation takes a lot of time. All right, what time we are now in? Okay, here you go. So if you summarize, that's it. Short-term behavior, if clay, saturated clay, only the first term matters. If it is long-term behavior, drain, only the second term matters. You see, there are 3 terms in bearing capacity equation. For the clay, only the first term matters. For the what other type of sand or sand soils, only the second term matters in our bearing capacity equation. Is all right? Okay, so let's do, I know you are already confused a lot, like me. So let's do one of the problem to using these all equations so that we will know how to use these individual equations and so on. Can we do now one problem before I finish this, because I took a little bit long time. Can we do this now? Can you make ready your calculator, piece of paper and a thing? So we try to use several methods. Of course, I haven't covered the Meyerhof equation and so on. So I'll not go to the Meyerhof now, but let's start doing things. What is this problem? This is the tutorial exercise 3.1. Again, based on the list, we have several methods. We can use Terzaghi method, we can use Hansen method, we can use many methods, right? Can we use that now? What is the question? Question is a point of the pile length is 25 meters. You see, that long. From here to here is 25 meters. Is that 25 now? 5 here, 18.5 there, 1.5 there, right? Okay, so that's good. So this is total of 25-meter long pile is founded in the dense medium coarse sand. This is on the sand, right? So unit weight is this much over here. Unit weight over here for that sand is how much is it? 17 kilonewton per meter cube. But over here is about, I think overburden something, unit weight overburden is what? 16.5 kilonewton per meter cube, right? So water table is 5-meter depth, saturations average, during that time and average. I haven't covered this part, all right? Just leave it. So phi is 36 degree, and this IRR, the angle of plasticity they require in the equation also given here, right? So now, this is the HP pile. This size HP piles with 2 dimensions are given by this data, right? Let's use all of those bearing capacity equations one by one. Can we use now first equation? What is the first equation we learn? Can I go back to, I discard that now. Can I go to my, what equations we use the first? I wanna bring my writing pad first, okay? Presentation, this one. This would be easier to write. So can I do side by side so that you guys know, right? So now, side by side, what's the formula? So this is the one I'm doing, right? Okay, SP pulse. You can see, right, both of these. Okay, so now let's write here. So can I just remove this also so that it will be bigger in writing? So now let's do this first method, right? Okay, tutorial exercise. Can I do now? Just move to this side and then pen. And then can I write here? So that one. Okay, so tutorial exercise 3.1. So what we are doing is only the pi point capacity. That means there is a pile, right? We'll be calculating what would be the total end bearing capacity at the tip of the pile only. We are not talking about shaft now, right? So now we don't use just the point capacity only. So what is the method one? Can I go back to my methods I discussed at the beginning? Yeah, let's say first method. First method is Hansen method. So we use the same bearing capacity equations, right? We learned before. So can I use that now? These are the Hansen method bearing capacity equations. Can I do now Hansen method? So what is the ultimate capacity now? Can I write the basic equation first? Yeah, this equation. So total capacity is point capacity from Hansen method, right? You can see my writing, yeah?
Yes.
Okay, thank you. Yeah, I'm just a little bit worried whether you can, because I'm trying to write side by side. So okay, so P, what PU point capacity, ultimate point capacity would be what? Area of pile. So that CNC, yeah. So DC. Of course, I already said SC factors are 1 because we don't use that much because shape of the pile at the bottom is not that variant in length and the width, right? So just write that plus, what is the other one? So in this value, what is that? I don't know, that's the symbol, overburden pressure, NQ dash, right? This is the NQ value for this, NQ dash for Hansen is same as bearing capacity in our shallow foundation. And then again, DQ, yeah, plus half gamma B, okay, so B at the point, right, at the point, width of the point, and then N gamma and S gamma is always 1, right? So depth factor is not associated with, right, this one, third term, right? So that's S gamma. So what I do now is I try to calculate now, what is the area of pile first? How much is it? in our case? Can I go down to what the problem is? So area is how? This is the case, right? So what is the area of the pile? That is the swell plug at the bottom, right? Can I do that now? So what? D1 times D2, right? D1 times D2. How much is it? Can you just interact a little bit? 0.361 times what? 0.378. How much is it? Can you compute using your calculator?
0.136.
Okay, so it would be 0.136. Now we change into meter square, right? So AP we already calculated now, right? So what is this term now in our case? 0. Why?
Is 0, no.
This all first term is 0 because it's a sand. Sand has no cohesion, right? Yeah. So only the clay has the cohesion. So only the second factor. So n value for Hansen method is always 1. Only the basic method, he has given the another equation. You can see in the lecture note. So can I calculate Q dash now? How much will be at this point? What will be the effective overburden pressure at this point, the bottom of the pile? So let's start from the top. What is the unit weight of overburden? 16.5, right? Times the 5 meter, right? 5 meter. This is just, I'm doing the first part because there is no water table first, right? There is no water table at the top. So now water table starts. How we calculate now? 16.5 minus, right? Because it need to be effective. It's not the total, right? So 9.81, yeah? This is the second, this is the saturated, this is the effective, and multiply by how much? 18.5. So then what is the other one left? So the bottom one, this is already given, right? What is the value given for the, there is a different value for the end of the pile. It's a 17 kilonewton for this bottom part. So kilonewton per meter cube, 17 times what? One, oh no, there is a water also, right? Can I do that now? Minus 9.81, right? Multiply by 1.5. This is the effective overburden effect. Okay, overburden pressure at the end of the pile tip, right? Can you calculate that for me? How much it would be? What I did is I did layer by layer, right? First layer, second layer, and a third layer. So that's what it is. So but because I reduced the water pressure because of the effective overburden pressure we need, right? Vertical stress. Come on. How much is it? How much you calculated?
$217.
217, right? That's a Q, right? Pressure, right? So now 217 to, can I do that one? I'm not sure why color is not showing. 217 kilopascal, right? Or kilonewton per meter square. We calculated that now. It's already done. So I need what? NQ value. NQ value I need from the what? Table, Hansen table. Can I go back to the Hansen table now to see what is the NQ value? What is the Hansen table? That one, right? Hansen method. So NQ, what is our angle of friction for the sand? 36, yeah?
Yeah.
36, right? So NC we don't need. So only we need is NQ and N gamma, right? Yeah, there is a gamma. So gamma also we can neglect. I can show you later on, all right? Just the NQ is the most important part. So NQ for 36 is how much? 37.7, is it? Do you understand how to look at this NQ value? So now you need to calculate DQ. Okay, DQ, they have given the explanation about what the depth factor for the second term here. You see, DQ value. Look at this now. DQ depends on this equation. That's the same equation is that. If you see this is the same equation, right? That equation is the same. So why not you just straight use? What is L by B? How long is the pile and the width ratio around? You can see here, depth becomes like 1.62 most of the time, but you can use the equation. Can I do that now? So dq, can I go to the next slide? Okay, so dq I'm calculating now. So now, come on. So it will be dq, depth correction. Shape correction is not that important for PAL, right? So we are not doing that. So dq equal what? 1 plus, can I write this equation now? dq equal 1 plus 210 phi, 1 minus sine square, 1 minus sine phi square. Yeah, and then 10 inverse L by B, right? So I think that is also given in the table, this part. You see in the bearing capacity, the table, Hansen table. So that's given, right? This one, 210 phi, 1 minus sine square. I can use directly that. What is in our case? 0.247? Okay, 247 now, right? So now how much it would be? Can I do that now? So it will be 1 plus 0.247, 10 inverse. What's the value for the length? How long is the pile? 25 meter, is it? Yeah, divided by width. Usually we take the minimum width, right? Come on, can I go back to my problem? You see, this is the width and the what length and the width, right? The cross section of the HP pile. So in this case, we need to use the minimum one as a width and the maximum is as a length, right? But okay, so can I do that now? How much it would be? 0.361, right? How much is the depth factor now? Correction factor. Come on. It's not showing me the color. That's the problem now. Yeah.
$23.
23.03. Yeah.
How much you got?
23.03.
The DQ. Oh, that's very big. What happened? 10 inverse. No, it should be, depth factor should be very close to 1 or 2. It shouldn't be that big. Can I do my calculation? What happened? Can I do now? So this is the calculator, right? So now 1 plus what? 0.247, right? Times 10 inverse is 810. What is it? Inverse 10, right? Okay, can I do first the other part? So 25 divided by 25, maybe I'll do from there. 25 divided by 0.361, right? That's the value inside. So this is 10 inverse, right? What is 10 inverse? 10 inverse. Oh, what happened?
Are we supposed to take in radians?
I think it's radian. Oh, okay. So calculator should be in radian. Otherwise, it shouldn't be that big value. 25. Is it 25? Is what was 25? Is the length, right? Inverse. Oh, yeah, radians. Okay, good. Can you convert this? This is degree into convert into radian what? Times pi, right? Pi divided by 180. Oh, thank you. It should be radian, not in degree. Okay, so 1.55, this second part, right? That part multiply by 0.247. I got the second part, and then plus 1. Yeah, 1.38. That makes better sense. Okay. So can you please, guys, to convert this into radians? Okay, come on. Where is that? Because factors correction shouldn't be that big anyway. So inverse, where is the pen? That one, that, right? So this is in radian, all right? Convert into radian. So it would be total is 1.38. Okay, depth correction. So do we have every formula now ready for this? Yeah, we have B also, we have gamma at the tip also. N gamma value is how much is it? Can I get from the table? You can directly read from the table for Hansen, and then you can also compute for that. But third term will be very small. What is that gamma? And gamma for Hansen, that one, right? So how much is it? 36 is? How much the value n gamma? 40, right? Okay. 40, this one. This is 40, right? Yeah, so everything is known. So S gamma is always, usually we take 1. I explained that before in the lecture, right? So we don't use any factors most of the time. But Terzaghi we may use because there is a specific formula, but usually yes, say factor 4. We can use this also if you want, right? But again, it doesn't affect that much. So I'll show you how it is done, all right? Okay, come on. So can we compute that now? All put the values now? What would be now? Ultimate capacity based on Hansen method? This one, what is this? This is the one. Okay, here you go. So now, can I calculate what is the formula before? So AP, what is the AP we have now? Yeah, PPU. PPU, the point capacity using the Hansen method. What is the area we calculated before? 0.1. How much was that? 136, right? Yeah, 136. And then first term is 0, right? First term is already 0. I don't need to. So n value is for n equal 1 for Hansen. So I don't write that. Can I? Just to show you by writing, just in case, right? So this would be 1 times. All right. What is the next one? So Q, what Q value we calculated? 217, right? Can I do that now? 217 times, right? What's the next one? Next one is NQ is 37.7, right? Yeah. 37.7 times DQ. DQ we just calculated, right? 1.38. Yeah. So DQ, and then what's the next formula? I think we finished that part because yes factor we don't use really. Okay. So save factor. So plus half. Just want to show you. Okay. You can ignore that also. Plus half B, which is the smallest width of the pal at the tip. 0.361, right? That is the smallest tip B. And then gamma, what is the gamma at the bottom? Is the question given is, I think it's a 17, right? Yeah, at the bottom of the unit weight of the sand at the tip is 17 times, what's that one, other one? Gamma, that's done. SR is usually 1, that's it, okay? Can you compute separately, guys? Don't do it at one time. I want to show you why the third term can be neglected. Can you do that now? 0.361. Can you compute only this part, first part first? Come on. I hope we didn't miss anything, right? Okay, so we should be doing all right. Come on. How much is the first part?
1128.9.6. So 11,000.
11,289.6. Look at this, right? 11,289 plus. Can you compute second term separately?
6.6.
How much is it?
6.6 maybe.
Did we miss any factor there? Oh, so 7.5. No, we cannot use 17. I think there is a water, right?
40.
There is a water, guys. So 17 minus what? Minus 9.81, because I just forgot that water part. Just use the gamma because we need to have the effective anyway, gamma there too. Yeah. And then there is, I think, n gamma we forgot, right? Can I do that 40 somewhere? I think I have written there. You see n gamma 40 there. So can you compute now? Do you understand why I use effective? Because there is a water table above that particular point, right? So you need to use the effective unit weight of the sand, not the total unit weight, all right? Can you compute now? Sorry, guys, again. Because I missed something. In the different slide, I need to move forward and go back. So come on. How much you got?
51.91.
52.91. Look at this.
51.91.
Look at the impact. Look at this. This is second term, right? Second term. This is third term. How much is the effect now? Third term. Look at this. Just 52. That was 11,000. Look at this. This third term really you can ignore most of the time. You understand why we are ignoring the third term now? You get that idea. That's what I want to show you the calculation, right? Because this third term in the bearing capacity equation has almost no effect, negligible effect in the ultimate bearing capacity of the tip. Okay, so can you compute? Okay, keep this for now, and can you compute how much you get overall? Keep for now, but again, most of the time it can be ignored, right? You know that now. Why? Okay, so I'll do another example also. Come on.
4,075.5.
Is this? So this 11,000, that one, right? Is almost 12,000, right? Total on 11,000 times 3. Is it that big?
1542.44.
1542.44.
42.44.
Is that? Can you check again one more calculation, Daniel? Come on. Yeah, that looks better because this is the tip, right? Around 1,500, yeah. 11,289.6 plus that multiply by this in the front is there. So you need to multiply by area. Is good?
4095.
4095.
95.
Okay. Interesting. 40.
I am the same with 1542.44.
What happened here? Okay, I'll compute myself also. All right.
So actually, your is 0.136, not 0.361 at the front.
Oh, that's what I believe on, Daniel. Come on. So it's the calculation is, come on. Yeah. So can I do that now, please? Okay, so go to the calculator. It happens. All right. Compute when you do. Can I check the first one now? 0.361 times 0.37, right? 378. 136. Okay, so now I'm confused myself. What you said, Kain? Can you tell me?
It's a typo. When you pass from the second term to the last one, you just misspell the 136 and you put 361 instead. That's it. At the end.
At the end.
It's
136. Oh, yeah, that's a stupid type of typo. You see, yeah, that is 136, not 361. Okay, because that was what we calculated here, right? Before, can I go here? You see, 136 over there. All right. Okay, good. So this is all right, right? We got around 1,500. That's by one method. Can you do another one method, right? Before we stop here, and we'll continue after taking some break. Is okay? So what is the second method? Maybe don't use Terzaghi. Terzaghi is too conservative for this. Terzaghi is only for shallow foundation. Ignore that. Let's go to the another one. What they call? Basic method. Can I do now? Method 2. Method 2, basic method, right? Basic. So what this guy uses is, this n factor one more, right? Compared with others, right? Can I show you the equation now? Basic method equation. You see, this is basic method. This is the NQ value you need to calculate, right? Look at the way. You can put that in if you want, right? That's a very terrible equation to calculate the factor, right? But I want to calculate this n factor first. What is n factor for basic? You see, You see, n equal 1 for all others except the basic equation, right? So can you calculate that n factor? Others would be similar, right? Can I do that now? N factor equal what the value? 1 plus 2 k naught divided by what? 3. So this is the only extra thing in basic equation, right? Okay. All others, we can take the factors from there. Can you do that now? K naught equal 1 minus sine phi. That should be written somewhere. Oh, not here. So we will learn in lateral earth pressure theory, right? K naught is what the at rest lateral pressure earth pressure coefficient, right? It is equal to usually K naught equal. Can I do that now? K naught equal always 1 minus sine phi. Can you calculate K naught now? Come on. 1 minus sine 36. How much it would be?
.41.
Okay, come on. 0.412. 0.412. Can you put back this over there to calculate n value? You see, this is the only difference in basic method. Come on.
.608.
0.608, right? Maybe 608. Okay, that's all right. So now let's go to the basic and then check. There is a table, I think, for basic, right? What is that? This is the basic method. To calculate this, all IRR is given, isn't it? So you can put IRR in these equations to get NQ, but I'll get exactly from the table, straight table. So this is basic, right? So IRR given is how much? Is it 100, is it, in our problem? This
Yes.
is too complicated to calculate IRR. They use the software program to get that value, all right? But it's given here in our problem to check. So 100, so what is the angle? Angle of, oh, 36 is not given, right? Now it is. So NQ value, better to compute using the equation now. Hey, you see, exactly that's not given, right? So 36, but I can interpolate a little bit. Can I check now? 100, what will be? We don't need NC, right? The second term we don't need. So only first term we need is 83.78. Can I do that now? NQ value? So can I do that now? NQ value dash, NQ dash. We wrote dash for the deep foundation, right? NQ dash is what? 83.78. 83.78 when it is 35 degree, right? So NQ dash equal what? What's the other one, 40 degree one? 134.53, right? 134.55. 134.55 when it is 40 degree one, right? Isn't it? 40 degrees 134.53. No, 134.53. So 40 degree one, 193. That's the one. 134.53. 134. So what would it be? What would be 36 degree? Can you interpolate? Sometimes linear interpolation, but the best way is, again, guys, I'm not, because I try to do a little bit quicker. That's why I want to interpolate, but actually we need to use this equation to get the exact value. Do you want to use this equation? It looks quite terrible, so I don't want to use now. It's too big, right? But again, we'll get approximate value in between that. So what would be like? Can you give me the NQ out of this for 36? Come on. NQ dash, how much it would be? 36 is very close to this, right? Isn't it? Close to this value, because 36 is close to 35, then 40, isn't it? Just little bit. So how much is the difference between these two? Can you compute?
93.93.
Sorry, can you take?
93.93.
93.93. You interpolated, right? But again, this is just a linear interpolation. It is not accurate value, all right? You understand what I mean? You need to use this equation to calculate accurately, all right? Okay, I'm not doing that for now, just to show you. Can I just use 94 then? Okay, just to make sure easier in our calculations. Come on. Now we know everything. So dq is same as before, isn't it? Yeah, dq is same as Hansen method, isn't it? You see, this is what? This is basic also there, right? Yeah, basic. So dq is also the same as before. So we can use, can I use now dq equal what we calculated before? dq equal 1.38, right? Yeah, same as Hansen. Okay. So now you can also check from here, right? They have given the same equation here. You see, dq equation here also the same. Okay, so you can calculate dq using this equation. Okay, so you can, some values are listed here already for phi equal 36 degree, right? Okay, that's why 1.38, we already calculated that anyway. All right, okay. So now what is not known? I think we know everything, right? The same age and gamma is same age. Can we put now in the bearing capacity equation now? Come on. So now this is Hansen method. No, not Hansen. This is basic method. So now what I calculate now using the basic is I will calculate PU ultimate point capacity equal. Can I write the formula first? First term is not applied. Area of pile multiply by, I think basic has this n factor, and then Q, and then what is the other one? NQ dash, right? And then NQ dash, what's the other one is, NQ dash is there, DQ, right? Let's say ignore the other one. So half gamma dash is a gamma dash, right? Because of the water. So there is a B, N gamma, other terms we ignore anyway. So can I do now 136? So what is the eta value we calculate, Daniel, just before? 0.608, right? Yeah. .608, right? Times Q dash. I think we already computed a Q dash also, right? How much was that before? So 100, what is that? 217, all right? We already calculated that. So I can use directly that value here. So 217, all right, yeah? And then 217, what else is there? So NQ dash. So now NQ dash is there times, what is, yeah, what, how much we got? Approximately 94, is it? From the linear interpolation? Okay, 94. This is linear, it's not accurate, all right? So you need to use this equation to get the accurate value if you want, right? But for me, this is enough for now. Come on. Times dq is same as 1.38, right? Okay, plus half gamma dash. This is same. You see, everything is same as Hansen method. So this is what? 17 minus 9.81. Yeah. Times width is what? 0.361 width of the pile. Okay. And then multiply by n gamma was what? How much we calculated before n gamma? That's the same as we can use that also, because this effect of this is very small, right? Can you do now? How much you get? Equal to 0.136. What's the first term first? Only the first term, please. Come on.
17,114.7.
Okay, well, forget about point now. Come on. So second term is exactly same as before. So how much we calculated before? So 52, right? Okay, right. Let's 53. Okay. So if you do 52, how much we calculated exactly? 52.91, right? So this part is 52.91. Look at this. Again, comparing with 17,000, this is just 52. Okay, so that's, of course, this third term in the bearing capacity equation has almost no effect in the pile. So equal to how much we got total? Around 20 plus, because this is very big value compared with the previous one. Come on. How much we got?
2334.5.
2334.5. Okay, 4.5. So kilonewton. You see? So this is load already. It's not pressure because we already use the area. You know that, right? So area is this area we use. So it's a kilonewton value. So look at this. There is a difference. Only two methods we use. One was about 1500. Another was is about 2300. Actually, just because of, I think, some factors are, look at this. What? NQ is 94 in this method, right? Previous was, how much was that? Hanson NQ was?
37.
37. You see, that's the huge difference. But again, it tried to compensate using this n value. You see the n value here? The n value reduces a little bit, but it didn't reduce as much. So we use two methods, right? Hanson and Basic, right? Next, we'll use other two methods, right? One is Janbu method, and another method is, let's say, Meroff method, right? I haven't covered that until now. So, and compare all these results. We'll do that, right? Okay. So, but let's take a break because it's taking a long time. I didn't finish what I wanted to finish. I thought in the morning session, first session, I would finish this problem, but still there are two methods left. All right. Okay. So I'll try. So let's take a break. What time you want to start? Come on. What is the best time? Kasum?
10 minutes.
10 minutes. Okay, let's start at 10:50. All right, and then we'll continue from this problem, and then again we'll keep going if we can go further. All right, because I have a lot of things to cover. I couldn't finish this morning session. Come on. Okay, we will meet back at 10:50. All right. See you guys. Yeah.
All right. See you.